So welcome everyone to our Tech Talk webinar on data-driven infrastructure within the healthcare, provided to you by Arista Networks and Siemon. My name is René Proost, Sales Manager for Siemon, and I'm pleased to be joined today by my colleague Alberto Zucchinelli, Senior Technical Manager at Siemon, as well by Roland Wammes, Enterprise Account Manager, and his colleague Joris Klaassen, System Engineer for Arista. As a healthcare business, you already know that keeping up to date with digital transformation trends can be at times feeling overwhelming. So that is why we have organized this seminar to give you a heads up on how we can evolve your IT infrastructure today to support you in this transformation. Today's session will cover a wide range of applications, services, and technology approaches across the data center and intelligent healthcare environments, with a goal to help you deliver reduced cost of care, faster diagnosis, improve access to care, deliver higher patient satisfaction, and even reduce carbon emission through a truly intelligent data-driven network infrastructure. If you have any questions during the session, please enter them into the panel provided on the right-hand side, and we will have a short Q&A session at the end to answer them. Many thanks and enjoy the seminar. And Roland, over to you.
Okay, thank you, René. Good morning, everyone. My name is Roland Wammes, and I'm working for Arista as our account manager. I am responsible for healthcare in the Netherlands, and let me please explain the diagram you see now in screen. This contains three areas. In the middle, you see a blue marked circle with some topics that are relevant today or in the near future within healthcare. In the other areas, you see the functional requirements needed and the technical solution Arista and Siemon can offer you. Let's start with e-consults and remote care. As we know in the Netherlands, there's a shortage of healthcare personnel. And as mentioned earlier, costs are increasing and the pressure on healthcare personnel is getting higher and higher. So we need to find other solutions to be more efficient. Do more digital and less physical. Making more use of e-consults, augmented and or virtual reality, robots, and many more. Then about remote surgery and monitoring. Doctors, surgeons need high definition and real-time video to do better diagnosis and surgery at the same time. Nurses, students, and doctors need to be trained and using remote training facilities. Then about in-hospital AI and machine learning. Research and treatment can be improved with AI and ML. Treatment can be done in an efficient manner. New healthcare devices and robots. More and more devices are connected with the network. For example, wearables, mobile devices, IoT devices, robots, and many more. Then about insights and control of data. Who and what is making use of the network? Do we have the insights? Do we have the visibility? And is it possible to create reports for security audits? The network can help. Efficient use of digital equipment. Can we easily find our important and costly medical equipment? For example, infusion, blood pumps, wheelchairs, etc. And what about the user experience in the hospital? Do patients or visitors easily find their destination or get a notification, information? So let me give a recap of this. All these addressed points tell us we need a flexible, dynamic, and high available infrastructure. Arista and also Siemon have proven they can deliver this quality end to end. So that's a short explanation from me from the diagram. I will hand over it now to my colleagues, Alberto and Joris. Thank you very much.
Thank you. Good morning, everyone. From my side, I'm Alberto Zucchinali. I'm a Senior Technical Manager for Siemon. The scope of this presentation is actually starting from a very basic, I would say, intro about our approach, about Siemon approach to healthcare market and segment. In that sense, we can easily see how the move from the trend in the market refers to the fact that almost everything that happens in a hospital now requires a network connection. So adding this to this complexity is the emergence of virtual medical care. Sometimes we call that telemedicine or mobile health. Virtual medical care gives people online access to physicians via mobile phone, tablet, computer 24 hours a day. And while the vast majority of medical record keeping is already computerized, the push for universal and uniform records is viewed as an important step to cost control and better patient care. That the table we are showing right now just shows how many ports, according to this American standard, are expected to be designed and installed depending on the different departments, the different areas in a hospital. And you can see how big is that amount. From the data management point of view, we can see how this the amount of stored data continues to grow exponentially. Just to give an example, a typical magnetic resonance imaging study generates 200 images and requiring about 40 megabytes uncompressed, or a multi-slice tomography study can generate more than 2 gigabytes of data. So this network must be absolutely able to move large files around quickly, while also handling routine transactions like emails. All of these activities contribute to the vast amount of data being transmitted over IP networks. Of course, this has an impact, a direct impact on the physical layer. So the scope of cabling during all of these years was actually supporting current and future bandwidth for big data. So deploying the future-proof highway for high speed. The recent add-ons in that field relate to availability. That means edge performances, low latency, the add-on of power over Ethernet, which is a quite important topic. And last but not least, the compliance with the European Union CPR, so Construction Product Directive, which divided the different performances against fire and smoke, so safety features in different classes, where, for instance, that's just an example, B2CA is considered the top performing class, and this would be applicable for horizontal distribution cabling by using some kind of Cat7 cable, like the one which is shown here in this picture. Even for data centers, here and there, we can see some needs for even higher performing infrastructure. So delivering bandwidth up to 40 gig on a limited range. But again, this is a different topic, the usual topic of copper against fiber, where fiber now is a big challenger. In this sense, the cabling implications, we can see some kind of suggestions. In the past, the Cat6a message was really around 10G for data centers. And this is still valid, but today there is much more need to educate customer about the application outside the data center, which are best supported by Cat6a cabling. These applications tend to require either high performance or need to support higher levels of remote powering. the killer ops recommended or required for 6A involve both high performance and high power. The use of Cat7A with Cat7A cables with Cat6A connectivity provides a familiar RJ45 interface and can deliver greater energy efficiency, heat dissipation, enhanced video transmission, and so on. Fiber, of course, is still and is more and more present in this environment for higher bandwidth requirements for longer distances, and this would definitely have to be taken in consideration. And the last point, the star topology cabling system have the fundamental advantage of avoiding specific cabling system and running a simple and flexible, standardized, and easy to test infrastructure. Now I'll pass over to my colleague Joris of Arista for his part on this segment, and speak to you later.
Yeah, thank you, Alberto. So yeah, thanks for introducing the first and bottom layer of networking to us. I'm going to talk a little bit more about what rides on top. So very brief introduction. My name is Joris Klaassen. I'm a systems engineer with Arista Networks and responsible for the Benelux area. Arista itself is able to provide you with a reliable network across all of the places, well, in the cloud, as we like to call them. This means that no matter if you need a network for your healthcare campus or a data center environment or a WAN or maybe an edge or even a virtualized network, we do have got you covered. Arista provides network platforms ranging all the way from fanless 1 gigabits per second switches to 400 gig ready fiber platforms that can actually route the full internet table. And we do this by leveraging Arista EOS, which is our software suite that provides consistency across all of the networks. And EOS published to thrive architecture has been proven for years and years in the largest public cloud networking infrastructure, and it provides means to apply global network segmentation, internet scale routing capabilities, and complete programmability overall. On top of that, we've got a Cloud Vision management plane. Cloud Vision leverages the programmability of EOS by creating a time series network data platform, which enables customers to get better insights in what is happening in all of their networks, both real time and also historical. The data is then baselined by our analytics engine to give customers a proactive but also reactive alerting, also catering to automating workflows using our network-wide provisioning and change control workflows. And the system can also act as a network API gateway for other users of the system. So what makes EOS different? EOS is different because of three main reasons: culture, architecture, and testing. At Arista, no release is being done before a product is ready. So we simply disable parts of non-tested codes until we are sure that not just the code is out there, but it's also tested and actually meets our requirements. The architecture of EOS is radically different to that of typical legacy systems. Since all of the processes save their state information centrally in a process called NetDB, there is no direct inter-procedure communication, such as in the left example. This means that when a process fails, recovering state information is as simple as going back into the NetDB and request the latest version of the state. In the left example, there would be iterative communication between processes until the desired state would have been achieved. And a third big differentiator that we've got is testing. So when a development team within Arista develops a feature for EOS, they also develop a test case for that particular feature in our testing framework. And that testing framework allows us to continuously test all of the features on all of the hardware platforms that support a feature. If a test fails, the development team that had originally developed the feature would be alerted to have a look at that and also fix the issue. And this way we can keep regressions out and quality high. So let's have a look at how this helped us to stay on top of vulnerabilities overall. This slide is maybe a little bit shameless, and I apologize for the rather blunt comparison here. However, things like vulnerability rate, velocity, impact, and risk absolutely matter to life-critical operations such as in healthcare. Rather than focusing on the fact that we have got 2 orders of magnitude fewer organic vulnerabilities affecting Arista's EOS than our competitors, it is also equally important to highlight a few other aspects of transparency and risk management. First of all, we've been going back to the National Vulnerability Database and providing complete transparency. Every upstream software bill of materials related CVE, like Telnet or OpenSSH, is also receiving a link to the related Arista advisory. We built a proactive workflow and notification capabilities into our Cloud Vision management plane that determines your environmental risk and automates remediation. But even above that, over 98% of our CVEs, both the organic ones and also the ones that we inherited from upstream software bill of materials, have been able to be mitigated with non-disruptive patch updates that require no system downtime to implement. In the end, it all comes back to systems and software architecture. Moving on to the first real healthcare application that we see, which is big data. And big data itself is likely to transform the way that healthcare systems networks are being built. And the reason for that, to dive into the reason of that, I first have to dig a little bit down into what makes a typical normal data center network. So Arista Universal Cloud Network is the result of years of building the world's largest data center network. And in the end, the industry agrees. A leaf-spine network is really the way to go for simple, stable, and scalable networks. This particular architecture ensures a consistent performance for all of the racks and all of the systems that are connected to the network, providing both good latency and also good throughput numbers. It's quite easy to scale up and down while keeping consistent design patterns. Arista does not force any type of routing protocol within the UCN. Everything itself is fully standards-based. So this means no matter what you connect to the network, as long as it's open standards such as Ethernet and IP, you'll be good to go. Repeatable patterns in these designs are also great for automation. And automation itself, again, can also be done with either turnkey solutions, such as our Cloud Vision automation suite, but also with open source software, such as Ansible. So we're in a healthcare session, right? So why did I explain all this about data center networks? Let me try to explain. The main driver that we see for these type of networks being more valid for healthcare situations as well is artificial intelligence. Artificial intelligence, or maybe more augmented intelligence, it depends who you ask, has found its way out of research labs. And effectively, this means that we now have found real-world applications for a technology that we are just starting to know. Machine learning or deep learning has made modern applications applicable to real business value and, more importantly, also to health value. However, these forms of learning and training require a network that does not meet regular campus or data center network hardware. And this has everything to do with the nature of these workloads. Typically, they consist out of a distributed network of processors of some form that collectively try to solve puzzles. And this requires a non-oversubscribed network that allows any-to-any communication at all times. So we found a couple of healthcare-specific AI and ML initiatives across a number of subjects, and typically they are in relation to clinical data and efficiency. There are more and more picture archiving and communication systems, or PACS systems, out there that can be used to export image data and apply pattern searches on them. Correctly trained data models that scan PACS data can result in predictive diagnosis for some severe illnesses. Ideally, these data models would also be combined with information from data from medical documentation systems such as HER or EPD in Dutch. And data models can also be applied to further data such as client intake data, engagement data, to help clients make better informed decisions about their own health. Such a combined data set can then be used to prescribe precision medicine and in the end have a more efficient end-to-end workflow. We also see a lot of possible efficiency improvements. For example, combining the previously mentioned data set together with remote health or e-consults can result in a much more efficient use of human resources within a healthcare organization. There's even possibilities out there to optimize the in-hospital care by baselining what type of clients require certain amounts of care and making sure there's sufficient capacity in the hospital. So let's take a step back to networking. So how do these new developments impact the network side of things? We see that these AI interconnect pose a new set of challenges, and one that's not easily solved by regular network hardware, because they require a lossless fabric for any-to-any connectivity and bandwidths that typically are only seen in high-performance compute networks. So Arista's deep buffer portfolio, consisting out of the 7280 R3 leaves and 7800 R3 spine devices, is able to tailor to these new requirements. They can do that because they offer a fully non-blocking Ethernet fabric that can host pretty much any type of workload, either today or tomorrow. So this brings me once again to the physical side of things of networks like these. Alberto, could you please explain a bit more?
Sure, thanks, Joris. We have seen that actually active equipment could be connected in different modes by using either a full structured cabling infrastructure or via point-to-point direct connections. So depending on the areas of applications, each method would show some benefits against the other. Wherever an in-rack connection is needed, wherever an in-rack connection is needed, then a top-of-rack switch is expected to connect to servers in a close distance, and no physical reconfigurations are expected between those switching ports and the server ports. So direct attach cables are the preferred solution. This would limit the amount of cables and would save rack units in the cabinets. From the other side, backbone links have to connect to multiple levels of networking. This means spine to leaf, as Joris was mentioning before, rather than core to distribution to access layers in old-fashioned 3-tier networks. So these links have to cross-connect multiple cabinets and often different rows, and should share switching ports with the whole network in a flexible way. In accordance to international DC standard recommendations, this would see many benefits in a proper structural cabling infrastructure with patching features, giving a high level of flexibility, the chance of connecting anything to anything in a simple way, and add some physical routing redundancy for higher resiliency. For top-of-rack point-to-point links, we'd like to highlight the benefits of what we call high-speed interconnect cords. These are point-to-point pluggable cable assemblies directly attached to network equipment. So if we start from the traditional approach shown in the picture by having transceivers and associated jumpers, cabling and whatever, we would see here the transition into high-speed interconnect cables that could be either direct attach cable made of copper or active optical cable that are made of fiber. So what are the benefits of using a DAC, as we say, direct attach copper cable cord? Definitely the lowest price, lowest power drawing. It's quite low, as you can see, from 0.01 watts to 0.05, so really power saving. Very low latency pass-through cable. These are definitely no need for transitions from, let's say, copper into fiber and then backward from fiber into copper. Less operation, just because it's really like installing a patch cord with the advantage of incorporating the transceiver. Plus some add-ons, which you could find from I would say top brands in structural cabling like Siemon, referring to color cable jacket options. So more cable color option would create color coding and differentiate redundant links or link type, Ethernet or fiber channel, whatever. And even steps in length options. This might seem a negligible point, but this would prove to be highly beneficial for reducing cable extra length in racks, with an impact on better air circulation and lower cooling expenses. If we move into the active optical cable world, their benefit against DAC is a smaller cable diameter and a bit more flexible one. In some cases, this is the reason why some customers like AOC even for short distances, and even if they are some more expensive compared to DACs. So compared to transceivers with the jumper cables, so to the usual traditional way, AOC are cost effective, definitely efficient in terms of power, and assure the functionality of the cord for its intended speed. Another benefit of those cords is that they have an active chip with the capability of making diagnostics. So this is an additional reason for some customers to go with this kind of solutions in a general way. If we just give a brief look at the structure cabling option, we could mention the importance of having quick and flexible installations. In some areas with limited spaces available, it might be interesting to be able to terminate a mix of copper and fiber ports in the same panel, like the one shown here. And the adoption of pre-terminated trunks in data centers has become now a standard solution, allowing for very quick and reliable installation with a simple plug-and-play approach based on top quality factory-made components. This was, I would say, our side related to this chapter, but I'll hand over now back to Joris again, related to this real-time media in healthcare. See you later.
Yeah. Thank you, Alberto. So real-time media within healthcare, right? Real-time media, it's a little bit of a well, open subject as well, where there's quite some smaller parts within the bigger umbrella subject. And the first of them is the real-time, is the file-based workflows. But real-time media itself has been something that Arista has been doing for years. So our customer base has been leveraging IP-based solutions to help them with either these file-based workflows, but also the other real-time broadcast workflows and streaming OTT workflows. But if we zoom into file-based, mostly they have been transforming media in the widest range possible. And this is everything to do with the large amounts of storage that a network can cope with, and also traffic bursts within the network. But if we put, say, our healthcare view on, we can immediately see that there's a massive feature overlap between file-based workflows within media and entertainment and PAC systems within healthcare. If we move on to real-time broadcast, we see slightly different requirements. So customers within real-time broadcast are looking to transport uncompressed video streams with as little latency as possible, while not even losing a single frame, because this would give them a black frame. These days, IP starts at the camera, so it's all about transporting these media streams from A to B. And control systems can be applied to ensure more redundancy and reliability, even for the most extreme of failure scenarios. So if we look at the healthcare application of this technology, we can see that there's a massive overlap with remote surgery, as remote surgery also requires super high resolution imagery being sent over to a surgeon with as little latency as possible, while being super or very failure tolerant in nature. And the last media and entertainment utility we see being used a lot is streaming or over the top. This is the delivery of content while being able to deliver it on demand. Typically, this is compressed video, which should be made available at any device at any time. In the hospital, we see patient entertainment systems, and while this is something that's not always hosted locally, patient entertainment systems are leveraging similar technologies, which are common across almost every healthcare facility in the world. If we basically pull open the covers of what's under the hood of these technologies, we can see that the technologies that are required to make sure that media flows can go from A to B, they have a lot of overlap with other verticals, and it makes a lot of sense for customers to leverage Arista technology to transfer these media flows across their network. Arista has proven itself as a leader in the data center, proving that we can build a reliable standards-based network at scale while making use of reusable design patterns that allow for easy automation. In addition to that, a lot of our historical and current customers are present in the high-frequency trading or banking vertical. These verticals make use of multicast and P2P exclusively, which are the same technologies that are being used to transport video streams across Ethernet or IP networks. And they also require a very minimal number of latency for these flows. Combining all of these technicalities, we can see that Arista is an excellent fit to build a high-performance video network, such as in the following example. In this particular example, we can see multiple endoscopic cameras being connected to IP endpoints. These days, some of the cameras, or even some of the cameras, even have these endpoints built in. The endpoints would be connected to one or multiple devices that take care of Ethernet or IP transport, which in turn ensure real-time 4K or even 8K video shows up at the surgeon's desk, while also being mirrored to a nurse station for additional monitoring. And at the same time, a PACS system could also be used to save all of the image data that's gathered during the operation for later reference, either by a human or by a data model. That brings me once again to the physical side of these type of networks. Alberto, could you fill in?
Yeah, sure, Joris, thanks. Yeah, from our point of view, I would say just a brief touch on the topic that showing, I would say, how much all the audio and video applications have now this year shifted into the IP world. So many systems on the market have seen the presence of solutions and have been introduced to the market to enable ultra high definition video over a standard structural cabling with the usual distance coverage and with the add-on of power over Ethernet. So this kind of video real-time applications would see benefits of having the good infrastructure layer in order to support this, I would say, next generation applications for distribution of these systems. And even, I would say, more on the physical side, we can say that whenever copper and PoE is not the preferred choice due to extra length or required cable size or full EMI immunity requirements, so electromagnetic interference issues. So whenever the installation should be done out of a dedicated protected space like a data center or in an emergency situations like a break of the cables. So fiber installation should adopt some quick and reliable methods to ensure performances and to limit expenses. In just these two examples to the left, you can see a simple field termination method based on some form of mechanical splicing. The benefits that you can see listed here is just a very quick and easy termination or re-termination of your links by using connectors which are factory made, so factory polished. No need for splice trays, so no additional space required to protect the usual traditional fusion splices, and giving very good performances and top reliability. To the right, instead, you can see an example of an IP66 or 67 ruggedized termination, applicable for heavy environmental conditions like rooms with dust pollution or extreme humidity ranges, or even simple frequent deep cleaning requirements. So in that sense, some form of say different methods of installation or termination might prove to be winning. I'll get back to Joris now and see you for the last part.
Yeah, thank you, Alberto. So for the last part, we're going to zoom in a little bit on the healthcare campus network. And the healthcare campus network is a network that actually consists out of quite a few components. As stated in the introduction, Arista offers a wide range of platforms that can perform in different places in the network, or even in the cloud. This is a high overview of a typical hospital network with its endpoints, and we can see that there's multiple network locations, such as the campus or the edge network, the wireless network, the data center network, and the routing layer. Arista provides healthcare organizations with a single pane of glass across all of these network locations. This single pane of glass has deep integrations with ecosystem partners such as Medigate and Stanley for identity of medical devices and asset tracking, respectively. Identity management can be done through identity providers such as Forescout, but also integrations with ClearPass and ICE are available. The network is able to instantiate dynamic groups of network devices based on identity providers, which could be further enriched through Medigate. In addition to that, we have Awake, the network detection and response division of Arista, which has been integrated into our platform suited for access networking, and they provide a real-time threat hunting platform which can help to detect network breaches, which not just have come in through malware, but even through malintent, which means that there's just a bad actor on the network doing something harmful that might look good. Let's have a brief look at the topology view within our single pane of glass, Cloud Vision. Arista's Cloud Vision creates a dynamic map of the network based on the stream state information coming from all of the places in the network. This means that it can visualize an entire network, no matter whether that network is being used in a more campus-like or data center-like network. Dynamic overlays can be drawn on top of the topology view, allowing for visualization of issues and events that are currently or were historically active in the network. Using the flow information that can also be collected in Cloud Vision, it is possible to combine information from control and data planes respectively, creating an end-to-end heat map. Let's zoom into the edges of this drawing for a bit. Arista Cloud Vision also has integrated views and status reports for Arista access points that are used to provide the wireless network. The same software suite provides insight and compliance reports for both the wired and wireless network combined. Furthermore, Arista Wi-Fi has a unique controllerless architecture, which looks like this. The Arista Wi-Fi solution is based on a controllerless architecture, as said. However, it does come with a centralized management plane to keep up to the single pane of glass for management and telemetry of information. The control plane of the system is built in a peer-to-peer fashion between the APs themselves, based on the configuration that was pushed to them from the management plane. The last plane is the data plane. The data plane is local to the APs, which means that there's no tunneling to any controller of sorts. So you can select whether a SSID is terminated as either a local VLAN or external to an arbitrary endpoint using an open standard like VXLAN. So this means you can really send traffic from an arbitrary SSID out to any point in your network, because all of these switches support VXLAN in hardware. This separation of planes ensures ease of use for the network operator while providing massive AP scale, because there's no central point having to do all of the control. Typical Arista access points come not just with 2, but with 3 radios, of which the third radio can be used either for security, or it can be basically taken out of security mode for a brief moment in time, and it can be used for other utilities. One of these utilities is to put one of the AP's radios into a client mode and have it connect to another AP, and then run a test profile which can test applications, so it can verify whether your HER or EPD is actually working correctly, benchmark VoIP calls, or even do throughput tests. So effectively, this means that by using Arista APs, you can be sure that the network is ready for the day before any clinician has started their normal day shift. So much for some of the things that make Arista Wi-Fi different compared to other Wi-Fi solutions. Let's go into some of the technicalities of Wi-Fi as a base technology and see what implications they have on the physical network. Alberto, please go ahead.
Thanks, Joris. Yeah, back on the physical layer point of view, of course, Wi-Fi, we've been touching the topic of Wi-Fi, and this seems to be against the message of, say, a physical infrastructure. But we definitely have to say that Wi-Fi is now a need to have in healthcare facilities, both for patient care and for overall patient and visitor satisfaction. And the expectation is that it's always on, always fast, always easy to connect to. But due to the rapidly increasing number of devices connecting and the bandwidth required for each device, wireless networks can now be quickly overloaded and frustratingly slow as a result. 10 years ago, a single wireless access point would be connected by a single 1 gigabit cable and could support all the wireless devices within range with no problem. Today, not only are more advanced wireless access points needed due to the next generation of system from 802, so 802.11 AC as an example, but more access points are required to cover the same square footage than what was needed 10 years ago. In this table, you can easily see a comparison among the different generations of Wi-Fi 4, 5, and 6, where you can see that the border of gigabit has been now over by the Wi-Fi 5 that needs up to 2.5 or 10 gigabit applications. And this is actually a killing factor for cabling requirement, where Cat6a is definitely a must right now in order to be supporting the right systems, the right speed and applications. And even from the connection point of view, you can see that to achieve the maximum performances, these systems might require to have 2 connections instead of 1, as it was before. We'll be back to this topic again, but as I mentioned before, in the whole general, I would say, migration into everything over IP, we can see the need of providing power to systems via PoE, so via the structured cabling infrastructure. Just to refresh, the different types of standardized PoE, today we can see typically 4 types, starting from type 1 and 2, which are pretty old and anyway delivering 15 or 30 watts on 2 pairs. we can see that the latest levels of the latest types of PoE are now expected to deliver higher level of power, so growing up to 60 and 90 watts, working typically on 4 pairs with a 15% loss for type 3 and almost 20% loss of power along the link for type 4. So along this new standard, we can see also some improvements in power effectiveness, but all of this has a direct impact on the cable specification that would be needed. So in this sense, the implication of remote powering on the cable structure would be mainly coming from a potential temperature rise. So I mean, the first effect is power loss. That means cable heating increase the insertion loss, and this might mean to exceed the operating temperature. So we can mitigate this with the right installation practices. And the overall channel might need to be reduced in some cases if you don't take the good care of the design in cable to offset the increased insertion loss. A second effect, a potential effect, is on connectivity, so on arcing that occurs when unmating pairs under load. So whenever you disconnect a system which is powered, a potential arc, an electric arc, might affect connector reliability. Those effects have been partially countered with our power guard technology. That's actually a matter of complying with the best standard requirements in order to prevent these problems to happen. Regarding temperature, as I said, heat causes losses in a channel. So to better support PoE, it's recommended to use cables that are more thermally stable. For example, cables with larger gauge conductors, so larger diameter, exhibit less heat rise, which is the reason why Cat6a cabling has less temperature rise than Cat5e and Cat6. If we look first at the length derating due to the temperature rising, you can see that with referring to ISO standard, Cat6a UTP cable at 60 degrees will need to subtract 18 meters on the total amount allowed typically of 90 meters on a standard temperature. With a shielded cable, derating will be lower, so only 7 meters will be required to be subtracted by the total of 90. While with our Siemon cables, we have even better performances with the same kind of cable. In a whole, to counter the heat effect, we can just recommend to use a Cat7 or Cat7a cable that dissipates in a great way all power losses. So Siemon 7A cables do not need to be derated to support 10 gigabit, even at 70 degrees, because of their superior reliability, and so there will be full capacity of supporting 90 meters of horizontal links, even running at that temperature. An additional point to highlight is the need in a campus environment to add some flexibility in connectivity. That means giving some point of, I would say, additional elements where new elements or moves in existing ones could be flexibly managed. A standard-based zone cabling topology, like the one shown here, is performed by using what we call a service concentration point, or SCP. From here, you can distribute the service points with all of the benefits, including a quick and easy deployment of new devices via a spare socket. This will help, as an example, to switch to Wi-Fi 6 with a higher data rate once the need arises, fast reorganization and less disruptive movements, addition and modifications by isolating changes to the shorter wiring link between the CP and the final device, the user outlet. Convenient combination of sockets serving access points and other devices that have now to be considered part of the smart building devices in the same consolidation point or SCP. Zone cabling is especially ideal for deploying network-based Wi-Fi coverage areas. In this scenario, you can see that the diameter of the cells of the Wi-Fi coverage is typically larger than the usual square grid model to ensure reliable wireless transmission through a spaceless installation between coverage areas. That's an important example of how to use an SSP, and 7 or 8 hexagonal coverage areas are dedicated to serving access point only uplinks. With these emerging technologies, applications are already being developed using improved data rate reliability, and this could involve reducing the coverage area in some cases. While today we plan the Wi-Fi taking into account the layout of the floor and walls, it will now be necessary to take into account the number of connected devices and the speed required per device. That's the difference between coverage and capacity, but in that sense, a careful design of the physical layer would allow those access points to be connected in the proper way and be served by the proper bandwidth levels. If we look at the real Wi-Fi topology in the traditional way up to Wi-Fi 4, a single port was enough to support the data rate. The use of Cat6 cabling was also sufficient, and point-to-point topology was traditionally used, and the consolidation point was also used for flexibility of the cabling infrastructure in order to have easy moving or additions. Now we can see that for Wi-Fi 5 or Wi-Fi 6, 2 ports are recommended to support the data rate, and using Cat6a cabling to support 10G hassle-free. So some access points will still use only 1 port for Wi-Fi 5, but not with the full capacity of available speeds. So even for access points using only 1 port for data, they can use another additional port for out-of-band management system or another dedicated port for PoE. So anyway, in design of the physical layer, 2 links are anyway recommended to be designed in these situations. A benefit in the installation and in the practical world, an alternative to traditional installation is now considering to use a plug that ends the solid cable directly to the access point, what's called MPTL, modular plug terminated link. The advantage is ease of deployment and improved performances using PoE. This type of topology using plug instead of outlet and cords is now allowed and considered by standards. The test method is also available. We can say that from our side, we have developed a great solution that we call Z-Plug, which allows for termination of any typical data cable, should it be UTP, shielded, solid, or stranded, with the same component. And this plug will not only suitable for Wi-Fi termination, but also for a number of IP-enabled devices like audio, video, lighting, or cameras. So I would say that this concludes my presentation and our presentation. I'll drop to the organizer and back to you guys for any additional questions.
Thanks, Alberto and Joris, for your contribution in this presentation. So what we have seen is digital transformation is an ongoing process, as we have seen that many applications require, in my opinion, a true intelligent data-driven network infrastructure to support this journey. And I think that's the key in this session. We received some questions, but before we go to the questions, I would like to also inform you, especially for the Dutch audience, we are attending the Zorgen ICT, where you can meet us live. I will be there myself, Roland and Joris. And you can meet us in Utrecht on the Zorgen ICT on booth A089. So if you're interested, we are next week from the 14th to the 16th on that exhibition. One of the questions that I received was that I've heard a lot about intelligent buildings over the years, and it now looks like this technology is actually available. Are there any more barriers to adopt that you can see? So, Betta, I would like to pass it to you. Do you have any answers to this?
I would say, from my point of view, the only barrier is still in customers' habits or mindset. I would say that definitely different levels of intelligent buildings could be considered. So intelligent could be just simply considered as, you know, some kind of sensors distributed in order to check temperature levels or whatever, and going up to any kind of systems distributed in any building or in a hospital, as we are talking about healthcare market. But really, we see more and more solutions available and migrating into the IP world in order to have this smartly managed, to having a whole control, and last but not least, the benefit of having one maintenance department taking care of this with, I would say, not overlapping physical cables of different kinds or with different expertise required. So at the end of the day, having a best control of the systems will definitely give only benefits and no complication at all.
Yeah, I agree. And also with new constructions, I think it's very keen to sit together with all the departments, IT, facility, security, in a team to develop the needs of an organization that you can transfer into a smart solution.
Absolutely.
Another question that we received was, it all looks great, but I'm still using 10 to 25 gig applications today. Why do I need low latency, high performance infrastructure? Maybe yours, that's one for you.
Yeah, sure. I'll take it. Yeah, so I think with even though there will be a market for 10 gig, for 25 gig for a long time for specific servers, that won't really go away. But in addition to this, these new developments, especially the more AI related developments within healthcare, will require an additional parallel high performance network to work.
Okay, that's clear. Thank you. Another question: should I be using multi-mode or single-mode fiber in my healthcare environment? So, Alberto, maybe you can answer this one.
Yeah, I would say it's never black and white. Much less even now. We've been seeing during the past years that I would say campus environment might require some single mode fiber links due to the size of the campus itself, but mainly using multi-mode fiber applications on shorter distances. So that was actually the separation, and the separation was based on the price of the equipment, of the transmitters or the lasers. Nowadays, in data centers, for instance, we noticed that a number of standards have been developed in order to create, let's say, some shorter range single mode applications, which seems to be going to be a potential alternative in the world of data centers to the multi-mode alternative options. So in this sense, I would always recommend any customer to carefully check their needs, their requirements, the available budget, in order to see what would be the best fit for them. Having a chat with the experts, that could be Arista for the active equipment point of view, and of course Siemon from the physical layer, and having the best fitting alternative for them.
Yeah. And what do you see at the moment? Is it mostly single mode or multi-mode, or do you also advise for a specific type?
It's a mix. It's a mix. It's mostly dependent on the length of cables, and also specifically with 400 gig and higher, we see at the moment more single mode, more single mode transceivers being available. So if customers want to go like all the way to the highest bandwidth, single mode might be the safer choice.
Yeah, okay, thank you for that. The last question is again about cabling. You mentioned in the presentation about using shielded category Cat6a cable in some applications and for some applications. Why is this necessary? Why can't they just use category 6 or even 5e?
Yeah, I guess some slides already showed clearly the reason why Cat6a is now a mandatory requirement for I would say such a demanding environment like a hospital, or but anyway, we can split the answer in two parts actually: shielded and Cat6a. Cat6a is a must, I would say, whenever you would be considering anything over 1 gigabit, which is, I would say, very normal. So any 10G application would now require Cat6a as a minimum. And again, from the physical layer point of view, we are always required to design for something future-proof. So it's something that if not right now, it will be required very, very close in the future. And from the shielded point of view, definitely, again, an environmental at a hospital is plenty of different devices, high power devices, electrical distribution, and shielded will provide a much higher protection to any risk of interference from the external areas. And I would say Cat6a shielded would definitely giving all the required margins, even to the installers, for being sure that what they install today will be performing at the best for many years.
Yeah, I agree. And to mention, all the hospitals we have done in the Netherlands are done with a Cat6a cable, or sorry, Cat7a cable, 600 megahertz of higher. And also that's also related because of the CPR rating. We have a CPR rating in the Netherlands for hospitals for every installation, by the way.
Yeah.
And Cat7 is CPR B2CA highest rating cable. So I think we are almost 5 minutes over time. So yeah, again, I want many thanks for joining today to everyone who's listening. And if you're interested, we are happy to send you a copy of the presentation. Just shoot us an email and we are able to share this. So again, many thanks and take care. Thank you.
Thank you.
Thank you. Take care. Have a nice day. Bye.